What are some other forms of organic materials that can be used as fertilizers? Well, rock phosphate might be able to be used. Rock phosphate is the material that we mine from the earth. And if it were to react with water, it can form three phosphate ions or three orthophosphate ions. And I can tell you this reaction is highly limited at high pH values. It can be driven to the right in acidic soils, but even then, the reaction is relatively slow. It does work, but the reaction is relatively slow. And sometimes what we can do is we can take rock phosphate and partially acidify it to increase surface area for reactivity. And sometimes that increases the effectiveness. But I can tell you that fine grinding alone in a soil that's relatively neutral to alkaline will make rock phosphate laugh at you. It will not dissolve readily. So another source, and you can use rock phosphate. If all you do is mine it and crush it, it's organic. It hasn't undergone anything else in terms of an anthropogenic input to modify it. And if you acidify it, if you can acidify it with an organic acid, this likely can be marketed as an organic material or fertilizer. What about bone meal? This is crushed bones. And I can tell you that historically, crushed bones have been used for nutrients for fertilizers, including phosphorus. You can steam it. So you increase basically the surface area for reactivity. You would crush it first, then steam it. And the chemistry of bones or bone meal is almost identical to rock phosphate. So the issues associated with bone meal or bones or finely ground bones are identical to rock phosphate. So I want to give you an interesting real world example here. And so this is an example of some work that was performed in Ethiopia. And Ethiopia has a large livestock population. And they're sometimes raised in confined animal feeding operations, and they're butchered and the meat's used to feed people. But what happens to the bones? So typically nothing goes to waste. So those bones in an experiment were crushed and ground and underwent a few other types of modifications that I'm going to share with you in this slide set. So this is a study that was performed on ground bones, right? And that fertilizer, if you want to call it that, was applied to two different soils, a clay soil with a pH 6.3 and a sandy loam soil with a pH 8. Two different types of crops are grown, corn and common bean, and the bones were ground to less than 2 millimeters and greater than 2 millimeters. So sort of finely ground, not really, and not finely ground. And these underwent an acidification process for 3 periods of time. That's the bone meal itself that we're going to talk about. And all of this, in terms of crop growth, was compared to no phosphorus as a control or diammonium phosphate for comparison purposes. So this is what happened. These scientists in Ethiopia set up all these pots with different treatments and grew common bean or corn. And what did they find? So on this slide, what this shows you is the two textures, the clay or the sandy loam, right? Remember the clay had a pH of, was it 6.3 and the sandy loam had a pH of 8. And the bars in this figure show you the control, no phosphorus added, the coarsely ground bone or the finely ground bone. And what you see on the y-axis is the soil test phosphorus concentration. And what you see is there is no effect on soil test phosphorus concentration with respect to any of these treatments. There's no letters above these bars, right? And in fact, there was no effect on plant biomass. So that tells you something. That tells you that it doesn't matter if you're in a relatively low pH soil or a relatively high pH soil, and it doesn't matter if you finally or coarsely grind these bones, it has no effect on the soil test phosphorus concentrations. So the scientists thought a bit and they said, well, what if we acidify these bones or the bone meal and then apply them? And so that's exactly what they did. And they used a local source for acidifying the bones. They used a solution that was a waste product from the coffee industry, which had a low pH. And they acidified the bone meal between 0, 24, and 48 hours of shaking time. So what did they find? So, oops, yeah, I should mention that the coffee wastewater had a pH of almost 4.4. So it's likely going to react with the bone meal and kind of make it should look a little bit fluffier, i.e. an increase in surface area. So this is what they found. And this is well, don't worry about the Olson soil test P. This is the soil test phosphorus concentration. And we'll talk about this test in a subsequent video. But the soil test phosphorus concentration on the y-axis is here. And here are the treatments. Here's the control. No phosphorus added. Had a soil test phosphorus concentration of 100 parts per million. Here's diammonium phosphate. Had a concentration of 250. And now here is the coarsely ground bone or finely ground bone with no acidification or 24 or 48 hours. And if you notice here that it doesn't matter if you use coarsely ground or finely ground, and it didn't matter in terms of the length of acidification based on 24 or 72 hours. The concentrations of soil test P were equal to diammonium phosphate. So this is really, really interesting because what this tells you is you can coarsely grind the bones and you can acidify them for 24 hours and you get the same response as diammonium phosphate in terms of phosphorus availability in these soils. If I was a scientist, I would look at reducing the amount of acidification time from 24 hours to something lower with the coarse material. To grind bone to a size fraction greater than 2 millimeters will cost you less than passing it through a 2 millimeter sieve. And if you can get away with acidifying for, say, 6 hours, you can get three batches of this material created within a day versus one batch within a day. Okay, and then there's this last slide, and this shows you biomass yield. And the story here is very similar to the story on the previous slide. And we'll just jump to the chase. Okay, so the coarsely ground bone meal acidified for 24 or 48 or 72 hours, and the finely ground bone meal acidified for 24 or 48 hours, all, believe it or not, had a similar yield to diammonium phosphate. That's what the letters above these error bars or these bars mean. The graph doesn't show you the error bars, but there's quite a bit of variability, and thus that's why there's an AB above this. So this tells you another story, and it tells you that, yeah, you might want to still consider coarsely ground, and you might want to acidify for greater than 24 hours. And I would repeat this study with some other treatments or combinations of acidification just to see where is the sweet spot to help producers in Ethiopia meet the demands of phosphorus by their crops.